In this video, we'll introduce momentum. Momentum is mass times the velocity. It is denoted by the letter P, and it is equal to m times v. Now you notice that I put the arrow sign which indicates that momentum is a vector quantity. By definition, it is equal to mass times velocity. Mass is a scalar quantity, v is a vector quantity, so momentum also happens to be a vector quantity. Okay, so if an object is moving, it has momentum. If an object is at rest, it has zero momentum. If an object is moving to the right, it has positive momentum, left negative momentum. Okay, and if it's moving in some random direction, then you need to find the components of the momentum, and the x and the y components will have appropriate signs depending on the quadrant in which the object is moving. So once again, momentum is nothing but mass times velocity. It is a vector quantity, and the units of momentum can be obtained simply by looking at the units of mass and velocity. Mass is measured in kilograms, velocity in meters per second. So the units are kilogram meters per second. So let us apply a couple simple ideas to some problems. So let's say that I have a block of mass 5 kg, okay, moving to the right at a speed of 10 meters per second. Let's calculate its momentum. Okay, by definition, momentum is simply equal to mass times velocity. So it is equal to 5 times 10, which happens to be 50 kg meters per second. So that's straightforward. Let's also calculate its kinetic energy, and the kinetic energy will be equal to 1/2 times 5 times 10 square, which happens to be 250 joules. Alright, now what we'll do is let's find another object. So let's say that instead of a block, I give you a smaller block. Instead of this block, I give you a smaller block of mass, say 0.05 kg, and I'm asking to find what should be the velocity of this block such that it has the same momentum as the 5 kg block. Okay, so let's figure that out, and let's also calculate the kinetic energies. So for it to have the same momentum, we'll set it up 0.05 times v is equal to 50, and this gives me v equals 50 divided by 0.05, which happens to be 1,000 meters per second. So two objects can have the same momentum, and what we observed from the simple example is that the object with the lower mass will have to have the higher speed. Let's also try to see how the kinetic energies play out. Let's find the kinetic energy of the lower block. Okay, kinetic energy is equal to 1/2 times m, which is 0.05, times now 1,000 square, and this will end up being equal to 25,000 joules. So what you notice is that two objects can have the same momentum. The lighter object, on the other hand, will have the higher kinetic energy. Okay, and this is, we'll notice this later on, that this is the reason why the bullet is much more lethal than the gun itself. And we'll notice that when a gun shoots a bullet, it'll have the same, both of them will have the same momentum, but because the bullet has a lower mass, it has a much higher velocity, and as a result, a much higher kinetic energy. Okay, so when we discuss problems like that, it'll make a lot more sense, but just keep that in the back of your minds. Alright, so we can have two objects with the same momentum but different kinetic energies. Let us very quickly obtain a simple expression that relates momentum to kinetic energy. Okay, or if you're given the momentum, how to find the kinetic energy. We know from definition that P equals mv, which implies that the speed is equal to P divided by m. Okay, so now this gives me a simple relation for kinetic energy. Kinetic energy is 1/2 mv square. Let us replace the v with what we just found. So it will be P over m, the whole square, and this will be equal to 1/2 times m times p square over m square. One of the m's cancels out, and we end up getting p square over 2m. So if you're given the momentum, you can find the kinetic energy simply by doing p square over 2m. And let's say that you have two objects with the same momentum but different masses, okay? Then their kinetic energies will be, say, the first one will have p square over 2 m1, and the second one will be equal to p square over 2 m2. So now you can compare their kinetic energies. You can do ke1 over ke2 is equal to p square over 2m divided by 2m1 divided by p square over 2m2, and I can rewrite this as p square over 2m1 multiplied by 2m2 over p square. And you see the p's cancel out, and what we end up getting is that the ratio is related to m2 over m1. Okay, and if you look at the previous example, that's exactly what we got. The kinetic energy of the second block was 1,000 times larger than the kinetic energy of the first block. Okay, and that was precisely because its mass, 100 times larger, because its mass was 100 times less than the second block, than the first block. Okay, I hope that I didn't confuse you too much. So once again, the kinetic energy in the previous example of the 50 gram block, the 0.05 kilogram block, was 100 times larger than that of the other one because its mass was 100 times lower. So that's what it says here from this expression. Okay, alright, so that's it for now, and we'll do some more definitions later.